All right, everybody, welcome to solving problems. So the idea with solving problems here in chemistry is you always want to solve them the same way, develop a system for doing it. And I'm going to solve these 6 homework problems using the system that we have. Please check what I've done against your work. So let's get started. Okay, problem number 1. So in problem number 1, you have 24.0 grams of CO2. How many moles of carbon is this? Okay, so let's just make sure that we understand what we're looking for in this problem. Okay, we are starting with 24.0 grams, and notice these words right here, how many. Those are the question words, right? How many moles of carbon? So let's make a problem summary, always our first step to get this going. So we have 24.0 grams of carbon, and we want to say how many, that's that question mark, how many moles of carbon. So we're going from grams of carbon to moles of carbon, and we know that there's a relationship called molar mass that relates grams per mole. So that's going to help us. So the next step is to always set up a fraction. The fraction is easy. It is what you're starting with here over 1. And we're going to multiply it times another fraction, but we're going to take the units of grams of carbon, we're going to put them down in the denominator of the next fraction. That allows us to cancel them out when we multiply the fractions. And what's going to go on top? Well, we know that there is a relationship between grams and moles, and that's molar mass, so we'll go to the periodic table to get the information to put into this fraction, okay? So when you go to the periodic table, you're going to see carbon. Here's carbon, and remember, carbon atomic number is 6, and its molar mass is 12.0. So what does that mean? That means, if you remember, 12.0 grams for every mole. Now here's what I want you to see. This 12.0 is linked to grams. So put that down on the bottom with grams. 12.0 grams for every 1 mole. Okay, let's do the math. So we have cancel, love that. And 24 times 1 is just 24.0. And the unit that survived is moles. But we have to divide it by what's on the bottom, right? So we have 12.0. And so 24 divided by 12.0 is simply 2.0 moles of carbon. And to be really accurate here, since we have 3 sig figs in both those parts, there should be another 0. So 2.00. Check your homework. Many of you guys did that one correctly. Congratulations. Good job. Okay, so we're going to be doing this again and again. Watch the pattern repeat. Here we go again. I like to highlight this just to help you out. So we have 3.5 grams of that, or 35.5. And look, how many, there's that how many moles. All right, so let's set up a problem summary one more time. Okay, so 35.5 grams of H2O, okay, equals, there's that how many, right? How many moles of H2O. Okay, so now we know where we're starting, we're knowing where we're ending. It's the same idea, 35.5 grams of H2O over 1, okay? Now this unit has to go in the denominator because it's going to cancel out. There it is. And we know that there is a relationship between grams and moles, right? It's called molar mass. And we know that for every 1 mole of H2O, there are 16 plus 2 is 18.0. There are 18.0 grams of H2O. I just did the molar mass in my head, all right? So I made it easy for you. Okay, so let's do the math. So cancel, and you get faster at this as you go. So it looks like 35.5 divided by 18. Get out your calculators, guys. 35.5 divided by 18 is 1.97. And what unit survived? Moles. Mole of H2O. And that's what you were looking for, right? If you go back, you're going to see that that was the unit that you were solving for. All right, that takes care of that. Let's move on to number 3. Same idea, maybe a different kind of problem. Who doesn't really matter though, right? It's kind of always just going to be, that's what we have, And then what mass? What mass of what? Of carbon. So we got to be careful with what mass. Remember that mass is represented, mass is represented 3 times by grams, okay? So that just means grams. So let's set up the problem summary. 4.00 moles of carbon is equal to what mass? So that's grams of what? Of carbon, guys, right? Okay, so here we go. We got a problem summary. First fraction, 4.00 moles of carbon over 1. Okay, what unit's going to go on the bottom? Moles of carbon. Now, what unit's going to go on the top? Well, look, guys, is there a relationship between grams per mole? Absolutely, called molar mass. Done it a million times. So we got to go look it up, okay? And if you go look up carbon, you're going to see that there's 12.0 grams. So let's just write that in, 12.0 grams per 1 mole. Get your numbers in the right place. Don't put 1 gram per 12 moles. That makes no sense. So 4.00 times 12.0 is going to give us, that's an easy one, 48.0. And what units are left? Grams of carbon. Puffy cloud. Pretty simple, right? Let's do the same thing again, okay? So what do we have here? We have 1.50 moles. Let's highlight it. It helps you out. And look at this. What mass of CO2? Okay. By now, you should be kind of getting the hang of this. It's the same thing. 1.50 moles of CO2, okay, is equal to what mass? That's grams of CO2, right? Okay. All right, so now let's solve it. First fraction, 1.50 mole of CO2 over 1. Okay, what unit's going to go on the bottom? Well, obviously, moles of CO2 so that it cancels out. What unit goes on the top? Grams of CO2. And we know there's a relationship between grams per mole, right? Molar mass. And so, well, we got to add that one up. So here we go. Carbon is, if we look up carbon, I'm going to look it up just real quick because it's escaping. Is it 12? Yeah. So CO2, right? So we got CO2. So carbon is 12. Oxygen is 16. But there's 2 of them. So we've got to multiply that. That's 32 plus 12. I'm doing the molar mass for you, right, guys? 44 what? Grams for every mole. So put the 44 with grams, guys. 44 grams for every mole. See that? I just did the same thing up there. All right, do the math. 44 times 1.50 is 66.0. And what unit is left? Well, those moles are gone. The only unit left is grams. So you, my friends, have solved the problem. Good job. So you got 66.0 grams of CO2. Let's get to this next one because this is the alien problem, right? So let's solve it the same way. You have 2.50 of the compound, and I want to know how many moles. Problem summary coming at you. Always the same, 2.50 grams, and the alien compound is a little bit weird, has elements that are not found on Earth. How many what, guys? How many moles, so there it is, of the alien compound that turns you into a zombie? All right, so let's set up the problem. 2.50 grams of alien compound over 1. And we're going to multiply it times another fraction, okay? Of course, grams of alien compound is going to go on the bottom. And the reason for that is we want it to cancel out, and we want to convert it into moles. And why can we do that? Because we know there is a relationship between grams and moles. It's called molar mass. But this is an alien compound, so it's not on the periodic table. But look what you are given right here. with this information, you can calculate the molar mass. So let's do it. We have, in this compound, there's 3 of those and 1 of those. So that is 2.0 times 3 plus 4. Oh my gosh, 6 plus 4 is 10 grams for every mole. Okay, so put the grams with 10, so it goes down there, and mole with 1, okay? And guys, look, there it is, 10, 10, okay, good. So 2.50 divided by 10, uh-oh, you guys still there? Yeah. Okay, divided by 10, my computer went to sleep, it scared me for a second. If you do that, you're going to get 0.250 moles, okay? So did you solve this problem just like you solved previous problems? Absolutely. You just used an alien compound, all right? Why do I do that? I do that so that you cannot look them up in Google, right? You have to know how to use the process. Let's do the last one and be done with this thing here, okay? So the last one is let's highlight this, you have 30 grams and you're solving for molecules, okay? So the molecule amount of NO2. Okay, that's different. Let's set up the problem summary, okay, just so we can get a look at it. So I never worry, I just go like a little robot into my little system, right? And look at this, it says how many molecules. So I'm going to write that down. Now molecules is different than moles, everybody. They are not the same thing, right? So let's do this right now, okay? So we have 30 grams, okay, of NO2 over 1, just like we did before. We're going to put grams of NO2 on the bottom. Why? Because we know that we're not solving for grams of NO2, so let's get it to cancel. Now the question is, for this next one, are we going to put moles on the top, or are we going to put molecules on the top? Well, we've never done a relationship between grams and molecules, so let's not do that. We do know that there is a relationship between grams and moles. So if we could put in numbers, let's put in some numbers, let's add them up, okay? So we need to find the molar mass of NO2. You know how to do that. I'm not going to go into doing that right now because you already know how to do that. So we know that there are 46.0 grams for every 1 mole of NO2. And look what that does. That gets us to moles, okay? All right, so let's convert that, and let's do that right now. So that's going to be 30 divided by 46. So I'm going to get my calculator out, and I am going to do 30 divided by 46, and that's going to give me, ready for this, 0.652, and what's the only unit left? Mole of NO2. Now, hold on. We're not solving for mole, we're solving for molecule. So we need one more step. So watch this. 0.652 moles of NO2 are equal to how many molecules of NO2? Okay, so we have another problem. Let's do it. 0.652 moles of NO2 over 1, we've done it a million times, times, and on the bottom is going to be mole of NO2, and on the top is going to be molecules of NO2. This is the important step, because we know that in 1 mole of NO2, guess how many molecules there are? 6.02 times 10 to the 23rd. Do you remember what that number is called? That's called Avogadro's number. I know what you're all thinking. You're probably saying, Mr. Ashley, how come we didn't go to the periodic table? Well, people, we didn't go to the periodic table because we were not asking for the number of grams per mole. We were asking for the number of molecules per mole. So now let's do the math. Okay? Cancel, cancel. So we have 0.652 times the number 6.02 times 10 to the 23rd molecules of NO2. All divided by 1. Okay? All right, so here we go. Get your calculators out. 0.652 times, push the times button. Now, you want to put these buttons in the right way. Okay, so I'm gonna show you how to put them in. I'm gonna write down what you push. Push 6, push point, push 0, push 2, push E, push 23, and then push equals. All right? So I'm gonna now put it into my calculator. So times 6.02 EE 23 equals, here's my answer, 3.9. Oops, I wrote it down wrong. Spacey, Mr. Ashley. Here we go. Try it again. 3.93 times 10 to the 23rd molecules of NO2. So what does that mean? Okay, that means if you have 30 grams of NO2, that is equal to a lot of molecules. And that should make sense to you, right? 30 grams of NO2, that would be like, here's a balloon of NO2, because NO2 is a gas. And there's 30 grams of it right there. It's the same thing as that many molecules. 2 steps for that problem. That's how you solve it. Okay? All right, so be ready to do those kind of problems on your test. You will definitely see them. The 3 types of problems will be on your test.